Yeah, and we should start talking now about the it will be page around like the cerebral cortex. If you remember, I mentioned that we're having anterior and posterior parts, however, like the lobes and everything, right? However, we're still having there, it was mentioned in one photo, like the medullary cortex layer, right? So despite that they are like the medullary cortex, we're having some kind of structures inside them, right? So for example, in this photo we can really well see our medullary cortex, right? This is our medullary part and this is our cortex part, right here. So and let's discuss our cortex layer. Our cortex layer consists of the several parts, which several layers, it will be more correct to say, and it will be our molecular layer, our Purkinje cell layer, and our granular layer. So let's see these layers one more time. As you see here, we are having what I mentioned, like the molecular layer. This one is up there, it is our molecular layer, then comes our Purkinje cell layer, and then we are having our granule cell layer, right? To talk, like this is like crossing with the physiology, so it's like the same topic in physiology and in the anatomy mostly. To talk about our molecular layer layer consists of the stellate cells, which are taurine inhibitory cells. Also, it has our parallel fibers, which are our afferent fibers, and we're having efferent fibers, which are called Purkinje cell dendrites, and they are all located in the molecular layer. If you see here, we're having parallel fibers, which are afferent fibers, and efferent fibers will be like these Purkinje fibers, and they are both together our stellate cells, which are inhibitory, and also the basket cells, which are having like the GABA. How to remember that basket cells are having GABA? You can pretend that basket cell is our basket, and in the baskets we're having GABAs, and that's how it is. So inhibitory, you know that it is for reduction of some kind of nervous impulse, right? For the GABA, we are having again the parallel fibers and Purkinje cell stroma, and also like Purkinje dendrites here. Do you have any kind of questions regarding this? No. After that, we are having our Purkinje layer, and our Purkinje layer consists of 15 million cells there. It is really abundant with the cells, and it is also inhibitory layer, and there we are having our parallel fibers, climbing fibers, stellate 1 cells, and we're having also basket cells, and there we're having like the deep cortical nuclei, like efferent impulses coming from the deep cortical nuclei, and we can say that we're having Bergmann's glia cell there. To see the photo better, we can say how the basket cells and stellate, like the cells that we discussed regarding this layer, are located. So we're having here our Purkinje cells, right? And Purkinje cells and parallel cells, in between we're having basket cells in the molecular layer. If you remember that I mentioned, that are the ones who have GABAs, right? They are, let's say, bridging, they are cross-bridging Purkinje and parallel cells with each other. Regarding the regarding Purkinje and stellate cells, they are again cross-bridging our okay, there's again some kind of problem, I guess. Okay, yeah, no. We're having Purkinje fibers, which are connected with the parallel fibers, again with the stellate cells. Just the difference, as you see here, is that the basket cells are coming, like connecting the Purkinje cell nucleus, and stellate cells are connecting our parallel fibers with the dendrites, right? Okay. To single layered cells, and they are having like several the dendrites and the axons. The idea of the Purkinje fibers is that with this tree, with the dendrite, it is innervating the full layers of our cerebellar cortex, right? So they are like dendrites are perfused in the molecular layer. Also, they are having profused branching, and they are like having dendrite spines. For example, in this photo here, you will see how dendritic branches are with its spines, and see how the smallest nucleus and then the axon is starting, right? Axon mostly synapses with the deep nucleuses that we already discussed. Also basket and stellate cells, and also with the vestibular nucleus, right? Questions with that? No? Okay, one more time to see how they are located. We're having the stellate cells. Here we're having stellate cells, we're having basket cells, and we're having parallel fibers, right? So upper structures, what are mentioned here, they are our molecular layer, and also we're having dendrites, part of the dendrite. Then comes our Purkinje cell layer, where we're having our Purkinje fibers, and they are attached to the stellate cells through the basket cells, parallels, and stellate cells, right? Okay. Now we are having granulosa cell layer, and to see the granulosa cell layer, it is like these deep structures that are located on our granulosa cells. And there we're having even more abundant cells. It is like more than 50 million. And they are like, despite that Purkinje and molecular layer were inhibitory, right? From what we discussed, we're having granulosa layer, which is more excitatory, because there we're having glutamic acid, and glutamic acid, if you remember, is our excitatory. There we're having mostly mossy fibers, and as you see here, we are having these mossy fibers. We are having also like this is the afferent mossy fibers, like mossy fiber rosette, and we're having efferent, which were granule dendrites mostly. To see one more time here, as you see here, we're having mossy fibers and we're having granule cells, how they are located. Apart from that, we are also having our climbing fibers and mossy fibers, and let's discuss it more into details. We are having our climbing fibers. Our climbing fibers from inferior, they're coming from the inferior olivary complex. Direct, and their direct action is usually on our Purkinje cells, and they are giving us like really clear and sharp impulse to the Purkinje fibers. Also, they are connecting, like if you remember, I mentioned that our nucleuses are emptied down in the deeps of the nucleus, right? And they are transmitting impulses from the deep nucleuses to the cortex, and afterwards to like medulla oblongata or midbrain, like in another structures. So it is kind of connection of our cerebellum to different structures, right? Okay, now we're having white matter of the cerebellum, and if you remember, I mentioned that we are having mostly white matter in our medullary part of our cerebellum, right? And it consists of the three types of the nerve fibers in the white matter. We are having axons of the Purkinje cells, we are having mossy fibers, and we are having climbing fibers, right? The axons of the Purkinje cells, they are the only axons that leave the cerebellar cortex to the end in deep cerebellar nuclei, especially dendrite nucleus. We're having mossy fibers that they end in the granular layer, and we're having the climbing fibers that they end in the molecular layer normally, right? So in white matter of the cerebellum, we're having internal circuitry of some connect to cerebellar hemispheres. So we are having, is it clear, guys? Apart from this, we're having the afferent and efferent fibers that are leaving the pathways, leaving, let's say, the cerebellum, and they are the ones who are going to another place. For example, they are the ones who are connecting different structures, and we are having cerebellar efferents who are leaving via middle cerebellar peduncles, and also inferior cerebral peduncles. One more time, I will show you like middle cerebral peduncles and inferior cerebral peduncle. Let me see here. So they are leaving, like efferents are leaving via our middle and our inferior cerebral peduncles here, right? And we are having cerebral afferents, which are coming through, like impulses are coming into the cerebellum via superior peduncles, and they are the ones who are like coming from the fastigial. And from the fastigial we're having nucleus. We're coming with the our inferior cerebral peduncle. So one more time, our efferent is like the middle cerebral peduncle, and our afferent is mostly via superior cerebral peduncle. But like if the fastigial nucleus is sending some information, then it is coming from the inferior superior peduncle. Questions, guys, regarding that? No. Okay, now we are having our intrinsic, and when the impulse coming, the bascons and like this